What else I need to tell you? I want to show you how to apply P delta effect. There is a great audio in CSI Watch and Learn website that this is a part of your study for this week, but I will show you briefly how to apply P delta. There are two methods there. One is the combination of lateral and vertical load, which is option 1 in the video. It's not very practical for our modeling. The reason is you have different lateral loads, for example, earthquake and wind, and you want to see P delta effect on all of them. So I'll show you the option 2 here very quickly, but you can have a look at the video and be more clear about the explanations there. Here I just create a simple moment resisting frame with the define section by SAP. I applied some loads here. I can show you the uniform loads I applied here. So I put a dead load. The dead load is 10 kilonewton per meter. Just 10 and 100 both come here, so you cannot see it properly. But I have 10 kilonewton per meter load here on the beam, and I have 100 kilonewton concentrated load on top of the column. Likewise for live load, I have 6 kilonewton per meter load here. So if I close this and then change this one, again those are mixed together, but I have 50 kilonewton concentrated load on top of each column and 6 kilonewton per meter live load. So if I right click on the one of these joints and show the load, you can see 100 kilonewton dead and 50 kilonewton concentrated load. And also here I have 30 kilonewton on each column lateral load earthquake. So how can I apply the P delta? So I'm just going directly on the way that is better and more practical for our analysis, and I will show you how to use it. You need to create a load case here with the name of P delta for yourself. So I'm coming here, add new load case, and I'm creating a load case here, P delta. Then I need to apply the loads that I want to participate in P delta, which is dead and live. So you need to apply factored load. This is based on Australian standard, so I'm applying that's my factored load for dead and live here. And then I'm coming here and choosing static but non-linear. P delta is a non-linear analysis, but it's available in other versions, not just advanced version of SAP. You can find it in SAP Plus as well. You can come here and choose P delta. So you have a non-linear static P delta analysis with factored gravity load, and just press OK. Then I keep this one. I add a copy of this, and I will just put here, just for comparison, I put here earthquake X with P delta effect. What I need to do, I have exactly the same load case for earthquake X, but I'm coming here and I'm choosing linear static but a stiffness end of nonlinear case, which is P delta. And then I press OK. So I have earthquake in X direction with P delta effect and earthquake in X direction without P delta effect. I press OK. Then I run the model. We will go through all of those details later. I just want to show you the difference. So here you can see the moment 3-3 diagram for earthquake in X direction with P delta and without P delta. And if I right click here, you can see the moment here is 56 kilonewton meter, shear 30 kilonewton. And if I right click on this element, you can see the moment is 58.4 kilonewton. So moment is a little bit more, but the shear is the same because P delta effect coming from the effect of gravity, and that converge gradually when you reach to an stable situation. So let's check displacement as well. So this is for earthquake with P delta, and for this page or view I will choose earthquake without P delta. Yep, and I'll just right click on this. You can see here U1 is 0097, which is in X direction. Here U1 is more than 01, so it's more than 10 millimeter here. Here is less than 10 millimeter. A little bit difference is not too much because it's just a short building. If you have a high-rise building, the effect would be much more than that. That's how you can apply P delta in all your load cases. So what you need to do, just as a summary, I'm just unlike this, I'll show you again. You have a load case of P delta, which is the factor load that you want to participate in P delta effect, and this is a nonlinear case with P delta. That's all. Then you need to come to all your lateral loads, and what you need to do, you need to introduce that the stiffness at end of nonlinear case P delta. So that's all you need to do. You don't need to change any factor. You just need to have that P delta load case and show it here, and then P delta effect will be applied to all your loads. So I just prepared this model shortly to show you how you can do that. Let's back to our original model. So if I want to do this here very quickly, I'm coming to load cases, and I add a new load case, and I put it P delta. Then I'm adding all loads here. Just bear in mind the load case you created, for example dead, which was including self-weight and superimposed dead load, it's not here. So you need to choose them one by one again. So self-weight, say 1.2 very quickly, superimposed dead load 1.2, and live load 1.5. So this is nonlinear and P delta. I just show you how you can apply very quickly. So for example EQXP, I'm coming here, and all I need to do is mention here zero stiffness for a nonlinear case. It's automatically showing P delta because P delta currently is the only nonlinear load case I have. If I have more, you can see all of them here. So that's all you need to do. Okay, and the same for this one. Okay, very quick and simple. So I'm not doing this for Win, I'm just showing you very quickly that how it can be applied. It's not hard to do. In other CSI softwares like ETABS, it's very easy. You just need to click the button that including P delta effect and everything would be calculated. But for SAP, this is the procedure. Now the model is almost ready, so I save this model. I want to run the analysis. So what I need to do, I'm not going through the steps and procedures I want to discuss with you about minimizing the risk of having mistake. Intentionally, I have some mistakes in my model. For example, I have a point here with no connection. Or if I come to lower levels, let's back to the full view limit, show all, apply, close. It doesn't show me because I use show selection only for the group of steel frame, so I need to come here and press all. Now I can see everything. So here, if I go to lower levels, I'm coming here, I'm going down just to show you what I put intentionally as a mistake. I need to activate visible joints. So apply. Now I can see, for example, a joint here. This is actually a column I have between levels, and this is a wall I have between levels. So if I remove the loads, it's more clear now. So you can see there is a column here. I'm just trying to find a way to show you here. So this is Z0 to Z4. So if I come here and limit this view to Z0 and Z4, okay, now it's more clear. So you can see a wall here which is not connected to the slab. I just put the wall here. I didn't mesh the slab. I didn't do anything. And also I have a column here, and I just have a node here which is not doing anything. It's just if I go to upper level, so this node. So I have a point here with no connection. I have a column here again with no connection to the slab. There is no subdividing here. Likewise here for this wall. And the other thing that I intentionally left it, if you remember, I talked about how to connect these top beams to the wall. So if I make this one again full view and I back to the elevations in YZ direction, so here currently I am on this grid. So if I zoom a little bit here, you see there is no element here, and just these beams are coming on top of the wall. That's all. There's no connection. The other one, what I did, if you remember, I put a beam with stiffness, and actually this beam connecting the secondary beams here to the joint of the mesh of the wall. And if I go to this wall, so here if you remember, I just changed one of these elements here and I connected this one to the beam, but I didn't do it for the others. I believe I do this meshing here for edge point mesh type. So you can see here that this is already meshed for edge type. It's not subdividing, it's just meshing the shell. So see how it works, because as I explained before, if you want to put lots of meshes and lots of elements, that just increase the stiffness and mass matrices, and that will be more time consuming during analysis. So you can use the mesh like what I did, and you don't have to do anything else. So I have one wall meshed, one wall connected by beam, and one wall I didn't do anything. Let's see what's happening after analysis. So to run the model, let's back to 3D here. We need to come to analysis and go to set analysis option. So let's see what we have here. So here it just gives you the option that you want to actually run a space frame or shell or just XZ plane, for example. If I press here, you can see the degree of freedoms. If I come to shell, the degree of freedoms are different. If I come to 3D frame, degree of freedom is for all of them. So we will keep it as it is. And then in analysis, what else you need to do? You need to set your load cases to run. It's up to you that if you want to run all load cases or you don't want to run all load cases, just to save the time. If you're doing troubleshooting, you don't have to run all load cases, especially if you have response spectrum, because it's very time consuming to converge. So what I will do, I know that will affect my analysis, because I know P delta wouldn't converge if I have some errors in my design, because P delta is a trial and error process to converge the result, and if I have any kind of unstable condition, then that wouldn't be converged, and it may go forever, and you have to cancel the analysis. So the other elements I would like to choose and just put do not run are those elements. The other options you have here is analysis monitor option. You can see the progress of the analysis procedure on your monitor if you want. You can ask to show it after a few seconds. You can just put never shown or always shown. So I can choose always shown here, or I can put any seconds, I don't know, 10 seconds, 4 seconds, or anything to show me the result. If I want to monitor something, better to do it from the beginning, so I'll choose this one. The other option you have here is the messages after run. Do you want to see any message if there is any error? You want to see the message if there is any error or warnings, or you always want to see the message if there is even no error. So I'm choosing this one if there is any errors or warnings. And also the other option you have here is the model alive option. What does it do? Generally, SAP, when you run the model and complete the analysis, the model will be locked. So you're not allowed to do any changes in model because that will affect the result of analysis. You cannot change the boundary conditions, you cannot change the load, you cannot change the section sizes. But if you use model alive, when the model is locked, you can do any changes, but by doing any change, SAP will start re-analyzing the model and checking the result of design. That could be time consuming, especially if the model is very heavy. So I personally don't active this one, and I just unlock the model and do my changes and then run the analysis whenever I want. So I chose those options, do not run. Let's run now and see what's happening. So you see the results coming here. You can see very long periods here. That means something is wrong. The analysis is done. And this is the summary. I don't have any error, but I have few warnings. So the difference between error and warning back to the global stability of the structure or some local stability issues. So if there is something very wrong, you have an error. If there is something minor, like one column or one wall is unstable, then you have few warnings. And the warning showing that the structure is unstable or ill-conditioned. So this is one of the messages. The other message again showing the same, just checking the different cases and showing what's happening, and again the same message you can see here. So that's all warnings you have. So the model is run. In the next video I will show you how to do troubleshooting, and then we rerun the analysis, and after that we check the results.